let's get moving. We have a number of important topics to deal with. Most of them we are here now, as you can see. The first one of them is to, again, we should think about the validity of the model. And the way we investigate validity is in the first sort of go exactly like we did last time, once again, by studying the residuals, the deviations from the model fit. Those residuals, errors, deviations, are assumed also in the classical multiple linear regression model to be normally distributed, and with the same sigma all over, right? So no matter what x values we're talking about, we assume it's the same size of deviations we are dealing with. That's the model. And then, of course, that the structure is correct. And it's quite straightforward for us. You saw that last time. And actually, I'm not going to do it now for the sake of spending time on some new thing instead. We could just fit some kind of model, for instance, with those three, x1, x2, x3, and then we could do a normal plot on the residuals. Or go for Wally again. Because Wally plot is explicitly designed to take a fit from a regression model and do a Wally thing, right? Also, last time, we saw that we could and should to check for the assumption of homogeneity of variances. This assumption about sigma being the same all over. We plot the residuals versus the fitted values. And we look at the point cloud, and there shouldn't be any trumpet shapes or other odd shapes. It should be a flat shape, indicating that sigma is the same all over, right? If there is a trumpet, sigma is not the same. If there is a flat pattern, sigma is the same. If you're in doubt, do the Wally trick. One new thing. We could have done it last time, but now it's even more important to think about it. The new thing, or the extra thing we should remember, is to plot residuals versus each individual x. And why would we do that? Let's have a look. Here I have my fit, well, the normal plot. Oh, here's Wally. Which one it is? Which one looks the oddest among these ones? Well, not that one. That's not the one I picked. What's the conclusion when I actually picked another one? Probably my data is nicely normally distributed because there are nicely normal examples that looks more odd than mine. So mine must be pretty normal, right? So yeah, that's a good conclusion here. Appears to be okay. Residuals versus predicted. Is there a nice pattern here? Yeah, that's always challenging to conclude, of course. I'm not sure about that, actually. Maybe, maybe not. Depends on what size of contract we're having and how busy we are. What's the liability things going on? Anyway. Last time I tried the contract I'm working on right now with a British company actually, the first contract was okay, but secondly they wanted me to take personal responsibility of every R package out there that we could ever imagine to use as part of the contract. And if it didn't do as I promised them it would do, they could sue me and my family for the rest of my life. We're going to work on that contract a little bit until we sign that. Of course, DTU will help me. It's not a private contract. It's a DTU contract I'm talking about. Here I do what I suggested as a new thing. I plot the residuals from my fit versus each of the 3 individual x's. By the way, I signed a contract with DTU that they're gonna sue the butts out of me and my ancestors after I'm dead if I share something in those podcasts which I'm not allowed to. It's a good place to be working here, right? It's they are good friends. I tried to say, well, I'm happy to be with you. I mean, I spend all my waking moments working for you guys, and you're gonna sue the butts out of me if I say something in those podcasts as I'm doing now, which is illoyal or something. Anyway, after having several meetings with several people, I realized whether I like it or not, that's already the condition I'm working under, whether I sign the shit or not, so I sign. Sorry for taking the anecdote there. I love DTU. I would not be anywhere else in Northern Europe. It's the best university we have here, I'm sure. Yeah. Well, residuals versus, and then I threw in something extra that's actually not in the file you've downloaded. I may just update it. I threw in a little smoother here called the lowest smoother, just to look for tendencies in these plots, because that's why I make those plots. Those plots I make to check whether temperature is actually linearly influencing the logger zone or not, because there should be again a kind of a flat structure. If there is a systematic tendency from not being a flat thing here, maybe there is a nonlinear relation going on. Whoa, nonlinearity. Well, there are many patterns in your engineering life, I've said that previously, that actually, when it comes to it, might be nonlinear. So we need to deal with potential nonlinearities. We're having a linear model. It's still a linear model, even though I add 3 x's there. It's still an assumption of linearity in the way that the relations are. It's a plane. It's a linear plane that I put in. Maybe it's not the right model for the situation. Maybe we need to deal with nonlinearities. This one doesn't look perfect. I would be a bit worried about these. Of course, smoothers are smoothers, and maybe it's random noise. So again, it's a bit tricky, of course, to make the sort of explicit decision. Nevertheless, I'm worried. So we need to do something to deal with curvilinearity or nonlinearity. But we also have a game to play. Even though... just a check question. Easy for you now. And hopefully also easy for me. Full screen, sorry. Whoops. Whoa, not the right full screen. Here we go. Well, that's what I was just telling you a few minutes ago, right? So, good job for most of you, not so good job for the remaining 21. Guys, listen in, you guys, when I say something, right? And girls. Back on the top. So, when I get the answer correctly, we have a person there who is on the top. Curvilinearity.